Welcome to the second session of the second module in RAC. Students, in the last session we have discussed the vapor compression refrigeration system (VCRS), and we have studied to draw the cycle, draw the process or mark the process in a TS diagram. So it consists of four different processes: isentropic compression, constant pressure, heat rejection or condensation, then isenthalpic expansion, and then constant pressure heat addition or evaporation. So in the process of evaporation, actually refrigeration is taking place. So we learned how to draw this cycle in a TS diagram, and we also learned the actual working using the schematic diagram and all, using the various parts such as evaporator, compressor, condenser, and what, and finally expansion valve, or throttling, and a receiver. We also learned where to place a receiver. So now before that we will learn how to draw the same process in a pH diagram. What is pH diagram? Pressure enthalpy diagram. Pressure enthalpy diagram. So this is also important because in your syllabus it is asked to study both the TS diagram and pH diagram. Okay. So students, what is a pH diagram? A pH diagram is nothing but on x-axis we have enthalpy, on y-axis we have pressure. So students, you can see here that the vapor dome is marked with this red color, right? So this is our vapor dome. Okay, sorry. So this is our vapor dome. So this much area is saturated. From here to here to the critical point is saturated vapor liquid line. Means on that line, if the state of the refrigerant is actually present on that line, means it is actually saturated liquid. It is a saturated liquid. From here to here, it is saturated vapor. If the properties are present on this particular line, it means the state of that particular refrigerant is saturated vapor. So inside it is L plus V, liquid plus vapor. Here it is completely liquid, subcooled liquid region. The temperature is below that that of saturated liquid line. So here it is superheated vapor. Okay. So same as the case of TS, because in TS actually it is like this, the vapor dome is like this, but in pH it has got some kind of slope like this. Okay, the vapor dome is slightly slanted towards right. So that is the difference between pH and TS diagram. And another important aspect we have to learn or remember is that we have to note that constant entropy lines are like this. Constant entropy lines are like this. So these are the constant entropy lines. Okay, constant entropy lines, and it may be like this. So if it is extended to inverse, it will be like that. And constant temperature lines are like this. Okay, so these are the constant temperature line. These are constant temperature line. So these are constant temperature lines. So it should be noted that inside the dome temperature lines are like horizontal only. Outside the dome it will be like this. Okay, so temperature increases upwards. Okay, then then what, constant volume lines inside the domes are like this. So constant volume lines are not much of practical importance in our case. So students, this is how we draw different lines in pH diagram. So I've just shown you to understand how various lines are plotted in a pH diagram. Now we have a TS diagram like this for a vapor compression system, right? So TS diagram looks like, if this is the vapor dome, and if we are starting with saturated vapor at the inlet of At the inlet of compressor, let it be one saturated vapor, constant pressure. Constant 2 constant entropy, isentropic compression, then 2 to 3 constant pressure heat addition. So this is 2 dash, this is 3, and 3 to 4 isenthalpic expansion, and 4 to 1 constant pressure heat addition or evaporation. Students, now I will draw the same process in pH diagram. So in pH diagram, you can see your vapor dome will be like this. Okay. So students, the first point will be here 1. 1 to 2 is isentropic compression, means isentropic compression will be like this. Okay. So 2. So this is isentropic compression. Then 2 to 3 is constant pressure heat addition. Since constant pressure will be this way only. So 2 to 3. So 2 dash will be here. Since here it is pressure enthalpy diagram, 2 to 3 will be a straight constant a straight line or horizontal line parallel to x-axis. So 3 to 4 will be isenthalpic process, right? Isenthalpic process means it will be a vertical line. So this will be a vertical line, and 4 to 1 will be a constant pressure heat addition. So this is how we draw the vapor compression refrigeration system in pH diagram. So these are the different. This is a simple cycle. Okay, simple cycle. So based on this simple cycle, we are going to do some problems, and then we will move to some other modification. We will apply some modification to the cycle based on changing the positions of various states of by changing the states of various points, various salient points in this particular diagram, like 1, 2, 3. Like making this 1 inside the dome, or 1 outside the dome, 2 inside the dome, or 3 outside the dome. Such things we will apply those modification in later sessions. So for the time being, we will do some problem. Okay, problem based on this basic or simple VCR cycle. Before that, how to calculate the COP of the system? COP is nothing but, what is COP? Refrigerating effect, or required refrigeration effect by work done, right? Input work. Refrigeration effect is the required output or desired output by work. So here, students, what is the required effect? Refrigeration is taking place here, right? So the refrigeration value of refrigerated amount of heat, what will be that value? How could you get that value? It will be H1 minus H4. So Q refrigerator will be H1 minus H4, and W will be, what is W? Work in the compressor. Actually we are applying work in our compressor. So this is our work input. So it will be H2 minus H1. So students, you will get COP as H4 minus H1 by H2 minus H1. So this is the equation for COP. And students, you have to note that this H4 and H3 will be equal, because 3 to 4 is an isenthalpic process, means enthalpy constant. So if you get the value of H3, means it is also equal to H4. H3 is equal to H4. Okay, since H3 is present on saturated liquid, H3 means H3F. So students, very important, you require a refrigerant table. Like steam table, you require a refrigerant table. In refrigerant table, for each type of refrigerant you will have similar to the steam table. I will show you some saturation temperature. See, T sat, P sat. Okay, so some 10 degrees Celsius, 15 degrees Celsius, some temperature, corresponding saturation pressure, corresponding HF, corresponding HG, corresponding HFG, some value in kilojoules. Okay, and SF, SG, VF, VG. So for each particular refrigerant, like Freon 12, Freon 12, R134. For different refrigerant, we will have different tables. So it is actually tabulated for each. All these values are tabulated, and for different refrigerants, different values will be there. So the all the data for different refrigerants are combined together to form a refrigerant chart or refrigerant data book is there. So you have to buy that. You have to buy that refrigerant book, data book. Then only you can do problems, because in problem it will be only the temperature or pressure only will be given. The rest, the other required data won't be given. So you have to obtain those data from the refrigerant table. Okay, like you have did some problem in steam engineering or steam using steam table and all, right? Like in the Rankine cycle, you were asked to find the efficiency and all, right? So you did those things using a reference table, right? So here also, using steam table, right? So here also, likewise, you will be asked to solve problems based on reference data book. So try to get a reference data book at the earliest, so you can download some PDF copies from torrent or telegram, or it will be available, I think. Just try. Okay, so CP Balasubramaniam data book is there, or RS Kurmi is there. Okay, so just try to get any one of this data book. Okay, and now, so students, there are before doing problem, I will classify. I will classify the type, the vapor combustion system to different types of VCRs. So based on the position or the state of various salient points, we can classify into different types. Now I will introduce you the first type, cycle with dry saturated vapor after compression. So students, after isentropic compression, the state of the vapor should be dry saturated. So students, you have learned that the position 2 is somewhere here. So 2 is here. Here after compression 2 is some superheated state. But our classification is such that, or the type we are studying is such that 2 should be on the saturated vapor line. Then only it will be dry vapor. So 2 should be on saturated vapor line. So such type of system we are learning. So I will draw that type. So TS diagram. So this is TS diagram. So 2 should be here. So 1 will be somewhere inside the door. Okay. So 1 will be here. 3 can be here. And 4 will be like this. And so this will be our a cycle with a dry saturated vapor after compression. So this is TS. In pH you can show like this. So in pH it will be some 1 will be here, 2 will be here, and 3 will be here, 4 will be like this, and this will be our first type cycle with dry saturated vapor after compression. Now we will do some problems based on this cycle. Okay. The students, since in the question it is given, there is at the end dry, the working flow is dry at the end of compression, there is no undercooling. Okay, so just I will show you. Since it is dry at the end of compression, this will be like this, and 2 to 3. Okay, so 2 to 3 will be like this. No undercooling means if there is undercooling, then 3 will be after after some more expansion. So 3 will be somewhere like here. Some more undercooling, some more decrease in temperature will be there. So actually there is no undercooling. So 3 will be exactly in this position itself, and 3 to 4 will be like this, and 4 to 1 will be like this. So students, now given data are first one, pressure limits of 60 and 25 bar. So this particular pressure P2 equal to P3 equal to some 60 bar, higher pressure, and the lower pressure P1 equal to P4 equal to 25 bar. So these two pressure limits are given. So this is evaporator pressure, or PE evaporator pressure. This is condenser pressure. Condenser pressure will be always higher than that of evaporator pressure. So actually the compressor is compressing from PE to PC. 25 bar to 60 bar. Compressor is compressing the working fluid from 25 bar to 60 bar. So that is what happening. And what are the other given data? Now, so corresponding saturation temperature we can obtain. Corresponding saturation temperature. So since this is a TS diagram, okay, so this temperature will be what? 261 and 295 Kelvin. 261 Kelvin, 295 Kelvin. So T1 equal to T4 equal to 261 Kelvin. T2 equal to T3 equal to 295 Kelvin. Okay. Now what else? You can get this here. Every values are called enthalpy values are Hg, and along this line, and along this line it will be Hf, right? So the inner values you won't get, only the values at the saturated liquid line or saturated vapor line you get. So these values, so at 60 you have, at pressure 60 you have, this is nothing but Hg at pressure 60, and this is Hf. Okay, so this H2 is nothing but what? 293.29 kilojoule per kilogram Kelvin, right? So kilogram. And H3 is also the 151. H3 equal to 151. But H4 and H1 you can't get, but you will get HF4. HF4 you will get that the corresponding point here, and H1G corresponding point here. And also you have to note that H3 should be equal to H4 because this is isenthalpic process. Okay, now I will write all the given values. Okay, P2 equal to P3 equal to 60 bar, P1 equal to P4 equal to 25 bar, T2 equal to T3 equal to 295 Kelvin, T1 equal to T4 equal to 261 Kelvin, HF3 is equal to H3 itself is equal to H4 because this is isenthalpic process is equal to what? 151.96 kilojoule per kilogram. So that is given. And another value HEF H1 is there, right? Sorry, H1 is not there. H2 is there. H2 will be HG2 itself. H2 and HG2 will be same. Will be 293 kilogram. Kilojoule per kilogram. And directly and then what? HF1 is there. HF1 is HF4 itself will be same, and this value is nothing but 56, right? Okay, this is HF1 or HF4, both are same. So this is HG1 or HG4. This is 56 and HG4 will be 332 or HG1 will be 332. So this much values are given, and also entropy values also given. Entropy means SF1, SF2 will be 0.554. So this is SG2, this is SF2. So hope you know all these concepts, right? You might have already written this type or solved this type of problem in your chief engineering subject. So that is why I am directly going to the problem. I hope there is no room for much explanation because you already know the concept. So SF2 will be SF2 will be 0.554 kilojoule per kilogram Kelvin. SG2 will be 1.0332. It will be also equal to S2 itself. Okay, S2 itself. SF2 will be S3 itself. What else? SG1 will be 1.2464 and F1 will be 0.226. So all these values are given. So you study how to decode this table. What are the different values obtained from this table? Okay. Now we will solve the problem. So students, to solve the problem, what is asked to find? COP is asked. So COP is nothing but H1 minus H4 by H2 minus H1. So this is COP. So students, we require all these four different or three different values. So we can solve or we can find COP. So is H1 is there? So H1 is not there. HF1 is there. H1 is not there. Or this value is there. This value is there. This value is also there. This value, but this is unknown. This is also unknown. So we require H1. We require H2. We require H4. So H2 is directly given. So students, H2 is directly given. This you don't know. This you don't know. These two values is unknown. So how to find the value of enthalpy at 1 and enthalpy at 4? So that is the question. How to solve? So think yourself how to get the value of H1. Students, in order to find the value of H1, we have to use the entropy equation. So students, the entropy corresponding to this point is nothing but SF1. So that value is given. What is that value? SF1 is given. SF1 is given. So this is SF1. Okay. Students, you know the equation SF1 equal to, S1 equal to, so in your steam engineering you studied S1 is equal to SF1 plus X1 into SG1 minus SF1. So you might have studied this equation where X1 will be dryness fraction at 1. Dryness fraction at 1. Right? So if X1 is known, you can find S1. So SG1, SF1, all these things are known. But you don't know X1 still. So but S1 is equal to S2. S1 is equal to S2. Right? So since S1 is equal to S2, because it is an isentropic process, isentropic process, it gives S1 is equal to what? S2 is nothing but this value, right? 1.003. So that will be the same value of S1, 1.0332, right? So you can write the equation S1 equal to, you can substitute for S1 here. So 1.0332 equal to SF1 will be 0.2226 plus X1 into SG1 minus SF1 will be 1.0204, something like. So if you solve this, you will get X1 is equal to 0.791. So you will get the value of dryness fraction at 1 will be 0.791. So students, if you know the value of HF1 here, then H1 can be calculated. How? H1 will be HF1 plus X1 into HFG or HG1 minus HF1. That is, this is nothing but HFG itself. Okay. So HF1 is known, HG1 is known, HF1 is also known, X1 is also known. So you can calculate H1, right? So H1 is nothing but HF1 is how much? HF1 is 56.32. 56.32 plus 0.79 into some 322.58 minus 56.32. So you will get this value as some 266.93 kilojoule per kilogram. So H1 is obtained. Similarly, we have to find H4. So H4 is nothing but H3 itself. H3 itself. Why? Because it is isenthalpic process. So this value and this value will be same because H equal to constant in this line. So H3, H4 will be equal to H3. H3 will be HF3 only. So H3 you already written the value. So here it is 151.96. So H4 equal to 151.96. So students, now you can obtain the value for COP, right? COP will be H1 minus H4 by H2 minus H1. It will be some 266.93 minus 151.96 by 293.29. H2 is 293.29 minus 266.93, and value will be around some 4.36. So COP obtained will be 4.36. So this is how you find the various values of enthalpy. So you have to use the entropy equation and you have to find the dryness fraction, then only you will get the value for H1 and all. So since H1 is present inside the dome, you may require dryness fraction. Okay. So next question, what was the next question? So we were asked to find the capacity of the refrigerator if the fluid flow is at the rate of 5 kg per minute. So capacity means tonnage of refrigeration, right? So how to calculate capacity? The capacity will be based on this. So 4 to 1 is what our refrigeration takes place. So H1 minus H4 will be the capacity. So capacity is nothing but refrigerating effect. So it will be nothing but H1 minus H4. So H1 minus H4. Students, what is H1 minus H4? H1 minus H4 will be 266.93 minus 151.96. It will be equal to 114.97 kilojoule per kilogram, right? So the total capacity will be equal to m dot into H1 minus H4. So m dot means the rate of fluid flow. It is given as 5 kilogram per minute into how much? 114.97 kilojoule per kilogram. So this kilogram cancel, and you will get capacity as 574.85, and what unit will be? Kilojoule per minute, right? Kilojoule per minute. So you know, students, how to convert kilojoule tonnage of refrigeration to kilojoule per minute. So 1 TR is equal to some 211 or 210 kilojoule per minute, right? So this much kilojoule per minute will be how much tonnage of refrigeration? So TR, tonnage of refrigeration, will be 574.85 by 210. So it will be some 2.74 tonnage of refrigeration. So students, so this will be H1 minus H4 will be the capacity. Actually H1 minus H4 into m dot you should multiply, then only total capacity you will get. So this is how you do problems on this type of a vapor compression system. So students, you should be thorough with the thermodynamics or the property of the fluid at how to calculate the property inside the dome, how to calculate the property outside the dome, that is vapor dome, how to relate the entropy at the vapor line with entropy at the liquid line, how to apply the concept called dryness fraction. So what is the process, whether it is isenthalpic, whether it is isentropic, whether it is constant pressure. So all those things you should be thorough enough, then only you will be able to solve any kind of problem. So try to solve different problems. I will give some assignments, you try to solve all these things, then I'm sure you will be able to crack any type of problem coming across you. So for the time being, I'm stopping this session. I think the next class we will move to the second type of vapor compression system. Thank you.